Okay, welcome back. We're going to address the things on this list in no particular order. Whatever's the least amount of moving back and forth, I guess, is how I'll decide it. But anyway, it all has to be done, so it doesn't matter. Let's go after this airway diameter that's not ODA sized. And you want to get the accurate number off of the similar pipe, or the same model pipe from different times. And we know from checking those that the airway is 0.170 inches. Now the airway of this guy measured out at 0.153 or 154. So that's significant in terms of cross-sectional area. It would smoke differently because of that. And this particular pipe smokes magnificently well, as do the others. So modifying it is it guaranteed isn't going to mess something up, and it'll make it match its mates in forward and backward in time. So before we use them, a bit of information about the drill bits themselves. You don't want to use a bit in an unmodified configuration like this guy that's just square-ended. Great for drilling flat metal or something. Very bad for opening pipe airways, because when this thing gets to the end of the road at the heel of the chamber, it'll leave a ledge, and you want to eliminate the ledge and have it sweep up into a oval type of blending thing. It's graceful and functional both. So you take an ordinary drill bit and grind the end of it into the profile that you want. Now, it looks like all I did was chuck these in a drill and hold them up against a moving belt sander. That won't work. That would round over the edge, the cutting edge, and you'd end up with something that would not remove material. It would just sit there and spin and burn. So you get onto the internet and research a little bit about the proper cutting angles in the side view before you go wrecking drill bits and just wondering why they're not working right. There's a small amount of science involved, but it's highly worth the effort. I think you end up with a completely professional result. I've got a set of these in fractionals and in well, all of the different measurement systems just for this purpose. I don't use them to drill random holes in various materials. I save them just for this one purpose. So, also, you can, if you like, just chuck the, don't, by the way, put this in an electric drill and go into a stumble. Guaranteed it's going to pull it too fast, too far, and you'll come out here. I've fixed countless pipes people have mailed to me where they did exactly that. It happened before they were aware it was even going on. Now that hole can be plugged and refinished and all that, but much better not to go there. So this needs to be done by hand, whereas we are going to use a power drill to do this stuff here in a minute. But you can either chuck these shaped bits in a drill chuck and twist it by hand, but that's really tough on your elbow. Ask me how I know. I finally abandoned that method for something that's far easier. My body likes it better, and I wondered why I didn't do it years ago, which is just clip the drill bit into a small pair of vice grips, and keeping things aligned, all you do is keep, you've got like a handle for the bowl and a handle for here, and you just keep them in opposition in turning, and the amount of effort required is practically nil. It kind of cuts its own way through without needing much but guidance. It's really takes the work out of it. Now, every time the bowl comes around, you want to look down in the chamber and see if the nose of the drill is starting to emerge. And if it is, go very carefully from that point forward until you get exactly what you're looking for. Now, you still can go too far with these, but it's, you have to basically be sleeping on the job for that to happen. And if you do it properly, you will end up with a beautifully tapered ogive, and I never knew if it's ogive or ogive is the geometric shape that you'll end up with at the base of the bowl, or the chamber rather. It's really nice, both functionally and aesthetically. And then you just pull it off and you're cooked. Alrighty, so this half of the pipe is now what we want internally. We're going to go after the stem next. Before we do, you might get a kick out of this. Look carefully at the hole in the end of this tenon. If you needed any more proof, evidence that things were strange in this time period at the Dunhill shop, that hole isn't centered. Now, they used a lathe style cutter for tenons, but it's pretty difficult. You have to really be rushing to not even bother to center something like this when you're going to drill it, using the tools that they had. And it's off by a significant amount. And anyway, I just thought it was interesting as a telltale of how much time pressure they must have been under to put something through to out the door and not even have the hole, the airway, lined up in the tenon. Now, this is also a click too small. This happens to be that size, while all the other pipes are this one, which is a full 1/64 of an inch larger. Let's see, the smaller one here is, yep, we're back to 0.138 on this guy. And here is 0.152. So that's significant when you're talking cross-sectional area. So we're going to get this stem opened internally to the same dimensions as its brethren and sisterin over here. And we need to know the depth to go and all that kind of stuff. I'll shut this off and set up the camera in a different spot in the shop. And even though I already did it once early days, the attempted demonstration on how I opened an airway in a stem didn't turn out very well, because I had yet to learn the right settings on the camera for it to, excuse me, to stay in focus under those conditions, and I do a little better now. So it's a good time to repeat that. But I have to move the lights and so on over across the shop. So I will do that and turn it back on here in just a second. Okay, time to get a go here. I think it's going to stay in focus better, show the work better than the first time I tried to do this, so we'll hope. Anyway, I determined, and I don't need to, you don't need to watch me figure out the depth of holes and stuff. That's fairly rudimentary. I determined that by measuring the what I'll call the good specimens, that this size drill bit should go to that depth. And this is the so-called bad stem. It should go that deep. And then this guy, which is down a couple sizes, should go that deep. And again, you can do this by hand by twisting. Try it and you'll see why it sucks. It's really hard to be productive. It damages your elbow. It's a mess. Anyway, this is just an ordinary garden variety corded, not cordless, electric drill. And what makes this guy neat is it's got a speed control that goes down to effectively 0. It just barely works, or barely spins rather, on up to high speed. And it's very high torque. And what that means is you can control the rotational speed with one hand while you are feeding the material, aka the stem, with the other. And let's give it a whirl and see if I can do it with this silly camera in the way. And the way to get it to line up is just get it to bite and then let it spin freely like that, and make sure that it's not got a wobble in it. You don't want it flopping around. And once you've got it squared, add a little more pressure. And until that thing is all the way on there, keep checking in the same fashion. And then it's like power steering and automatic transmission. It just whips on there. No muss, no fuss. And all of this, of course, was the inside of the airway. And that right there is all there is to it. It's all in the tools. So, we're now going, whoa, grab the wrong thing. Go ahead, laugh, I can hear you from here. Now we're putting the smaller drill bit on, and we're going to continue to cut the hole, make it deeper. And don't wait till it appears at the end of the button, of course. You've got to measure before you begin this process, or you will be sorry. So, well, we're already there. There was no way to know that until actually getting in there and finding out. I got the depth right. The secondary hole, they did drill the same in 1973 to 76 as the other times. So using this drill bit was unnecessary. Only the larger one did it have to be employed, this guy here. So that is it. Now, to finish this, remember the slot is freakishly thin, meaning not tall. And that has to be made larger, and probably the funnel adjusted accordingly as well. But I can do that back at the bench. So I'm going to strike the lights and stuff from this position here, go back over there, and we'll keep her going.